Hello, my name is Stephen Bennett, and in this presentation I will talk about the implementation phase of low-tech PBR, focusing on the construction methods for PALS or post-assisted log structures and BDAs or beaver dam analogs. Here's an outline of the presentation. I will present a short review of the relevant components of low-tech implementation. Then I'll run through the steps of constructing PALS and BDAs, and I'll end with some common lessons that we've learned from building thousands of these structures. Much more detail can be found in the manual and the pocket guide. And just a reminder, we're in phase 3 of the planning process here, where we are implementing and then evaluating, learning, and adjusting. And this is a key part of the adaptive management framework that we use. And one of the questions you need to ask once you've finished implementing your plan is, have you accomplished your goals? And if not, maybe it's time to implement some more phases. I'm assuming that you have already developed a design package that contains these basic elements in this talk, and so I won't cover that here. That's covered in Module 4 as well as the manual. And generally speaking, we build these structures during base flow or low flow conditions. So that's an assumption too going into this presentation. Just a reminder that these low-tech structures are not just used to mimic natural log jams and beaver dams, but they're used to ultimately promote and sustain the processes of wood accumulation and beaver dam activity. Two principles of riverscape, low-tech riverscape restoration that are particularly relevant during the construction phase are make a mess. There's really no ideal engineered wood structure. Natural beaver dams and wood accumulations come in all shapes and sizes, and so you should be messy out there. Don't try to over design things. And strength in numbers principle, meaning that you should be building many of these structures rather than focusing on a few highly engineered ones. And the take-home message is, if you mimic messy natural structures and you build lots of them, good things will happen. This picture is a reminder that natural systems are dynamic, and we want to promote that. So this scene should be something you're comfortable with, where a PAL or a BDA has moved or been failed in one way or another and lost some of its wood. Wood needs to move to accumulate somewhere else, and so you should be building into your project some type of evaluation so you can see how your structures are behaving, and you may need to implement multiple phases to reach the self-sustaining healthy riverscape that we're all looking for. All right, now moving on to the main part of the presentation. I'm going to walk through the steps of constructing PALS, starting with a preparation, and just a reminder that PALS are used to increase the hydraulic and geomorphic diversity of the stream and riverscape. And most of the work that PALS do is during high flows, so they are more effective when you get higher flows. Just kind of linking back to the safety and logistics talk, you want to prepare your site, get rid of all tripping hazards, and just give yourself room to work. You also want to take advantage of the existing materials that may already be on your site and incorporate those, if possible, into the structures that you're building. And then you just want to get some basic things prepared. So we'll trim the branches off of larger pieces of wood that we're using to build PALS, so that the one side of the wood can have more contact with the stream bed. And especially when you're starting off, painting some guidelines on your posts help you see how far you've driven the post in. And you may want to trim your posts too. Often they come in 8-foot lengths, and that's awfully high to lift a post pounder. And so if you trim them ahead of time or have some idea of how deep you need to drive them, it will help. And then you want to get all your materials sorted. Often it's nice to have small branches, medium branches, and large branches of logs. And if you just have that all prepped on your site, things will go smoothly. All right, now just moving into the building of structures. And a reminder, I'm going to start with PALS, post-assisted log structures. And they basically come in 3 shapes and sizes. Bank-attached PALS that can either be used to scour pools or widen the channel. And mid-channel PALS, which are used to split flow generally, and channel spanning PALS, which are used to build upstream pond and grade the channel, capturing sediment. Okay, so when you're building, you want to take advantage of local features and use them for stability, increasing stability. So this figure is showing how we're building a bank attached PAL up onto the bank and tying it in with boulders and trees and shrubs that are already there. This is an example of another bank attached PAL where we're just using a small shrub on the right there and building the structure up on the bank a bit. And then we're also using a pre-existing boulder on the left to help constrict the flow, which will amplify the constriction jet. And here's the same structure after 1 year, and the flows are a little bit higher, and you can see that the boulder and the structure helping create this powerful constriction jet, which is scouring a pool. And even that little shrub that we tied into is managing to rack material and build that structure up and provide stability. Another local feature you should be looking for is sediment supply. And this is an example of a bank attached PAL that's used to widen the channel and harvest the sediment in the banks and induce meandering. And these are key processes for beginning the recovery from an incision, which this stream has got. It's down cut into the floodplain. All right, one of the first steps when you decide where you're going to build your structure and how you're going to tie it in is, what's the orientation of the material? And so I'm showing here you can either orientate a bank attached PAL upstream, across, or downstream. And many people have been taught in the past to build deflectors facing upstream. We tend to build them facing downstream or perpendicular, and that's because we've seen a lot of natural jams that are orientated this way, but we've also noticed that it really doesn't matter which orientation you use. They all kick off hydraulic change, shown by the arrows here, and ultimately geomorphic change. And so I would suggest you mix up your orientation. All right, I'm going to show a series here of slides on just building a channel spanning PAL, which just happens to be one of my favorite PALs. And so the first thing you're going to do is lay some of the key pieces of wood that you have and get the general structure and shape, and again trying to get some good contact with the stream bed by having branches trimmed off the bottom. And then you just start building layers, trying to keep the structure and the placement of individual pieces as irregular as possible, and trying to interlock the logs by putting them under or on top of each other and filling in spaces to get your general shape. And then, if possible, you pin the structure in with posts after you've got most of the shape made. The reason we do this is you are able to better lock the wood in place when you place the wood first and then drive the posts afterwards. It helps, especially with some of the larger material, if you angle the posts, and that stops the wood from floating up off your structure. And many times people ask, well, how many posts and where should we put them? And the answer is wherever you can get the posts to go into the bed firmly, and as many posts as you need. And this will just come from experience, and if you're not sure, maybe put more posts in, and as you work at the site and experience high flows, you might learn that you need less posts and you can start using less. Generally, we build these PALS to about bankful height, and try to keep the height of the structure less than the width, so that, again, it has some stability. Here's just some pictures of typical crest height of a bank or a channel spanning PAL, showing a slight pour over there, and an irregular crest height. Crest height isn't as and the flatness of it isn't as important for PALS as it is for BDAs. Here's a photo of bank attached PALS, and we generally slope them down a little bit. It just helps to force the water better to the other bank that you're trying to do and create that constriction jet. As far as how far you constrict the flow, we generally find that the more you constrict it, the more work that gets done, and so we usually constrict the channel 80 to 100% when possible. But in larger streams where you have a more mobile bed, you can maybe get away with a less constriction. In this case, we've got a PAL that's been there for 8 or 9 years, accumulated wood, and has got a 60-70% constriction and making a really nice pool here. As far as the shape of the structure goes, again, that's not that critical. We tend to make these wedge-shaped bank attached PALs, but just making them all the same width also works just fine. And in this particular example, we've got some really wide and messy and irregular bank attached PALs, and they do great work. As far as mid-channel shape, we often make these mid-channel structures with large logs perpendicular to the flow up at the head of the structure, and then trailing longer pieces to simulate a tree with a root wad that is the root wad facing upstream. Here's just another example, side view, and where we're integrating some boulders into the structure. And then here's an aerial view at high flow. You can see this structure, mid-channel structure, splitting flow and looks very much like a tree with a root wad. And channel spanning PALs, again, just messy, irregular, wide. And if your channel spanning structure starts to look like a natural debris jam, then you're building the right kind of structures. And then just quick notes on finishing off your PALs. That's why we sort material at the beginning. When you're using logs, there's going to be a lot of spaces in between those logs, and if you can start to cram smaller branches into those spaces, it's going to decrease the porosity of the structure and just make it do more work more quickly. Here's just another example of adding a lot of branches, and trust me, there is a stream underneath that structure somewhere. One of the questions we always get is, should you trim your posts or not? I like to trim them. I think it looks nicer. The other reason you might want to trim them is a lot of debris can rack up on the posts and end up toppling your structure over. But if the structure holds, well, you might actually be building a more complex and interesting structure. So again, it's a personal preference. No right answer. All right, I'm going to move on to the construction steps for PALS. Similar to the preparation for PALS, sort out your posts, sort out your material, and in the case of BDAs, avoid locating your structure near undercuts, because it's very hard to build the structure and seal and the structure if there's undercuts around. So now on to the building part of BDAs. Just a reminder, there's generally two types of BDAs, a primary BDA, there's two types of natural beaver dams, a primary one and a secondary one. The primary dam has a longer crest elevation and generally is built higher and is the place where beaver might have its lodge and store food. The secondary dam has a shorter crest elevation and a lower height, usually at or below bank full, and it's used to just backwater up and provide some stability to the primary dam, and then also just to provide deep water for beavers to move around. So I'm going to go over the steps for building both postless BDAs and the post line wicker weave. And those are the steps. So step one, select your site, and if you can find a site where the water is relatively shallow and you're closer to the bank full or crest elevation you're trying to get to, then you don't have to build as large a structure, and that's always useful. Other ways to sort of pick your spot, if you can build a structure, a BDA that will reconnect a side channel, that could be a good place to do that, which is what this photo is showing. Here's an example of just maximizing the diversity of flow paths and the pond size. So you get ponding and backwaters and overland flow and free flow here, and that might be something that you're trying to do with your BDA. The next thing you're going to want to know is how to orientate your structure to the flow, and in general, either perpendicular or convex to the flow works well, because the water either crosses a perpendicular structure and without really changing its direction, or if it's convex, it starts to spread out and dissipates the energy. Generally speaking, you want to avoid the concave structure because it will concentrate flow and potentially undermine your structure. So once you've got your spot, you can lay some branches parallel and then start to pack down fill material of cobble and dirt and sod. And you want to build these in small layers of 1/2 foot to 1 foot, trying to seal them up and keep your crest elevation uniform. You also want to source your fill material from upstream of the structure, and preferably in the pond area that you're about to build, because you're deepening the pond at the same time you're sourcing the fill. You don't want to source your fill from near the edges of the structure and potentially undermine it. You essentially then just keep adding layers in the 1/2 foot to 1 foot lifts, going slowly, and again keeping your crest elevation flat and trying to keep the base of your structure wide. As you're going, you can integrate the mattress, which is the branches coming out the back of the structure, to dissipate energy as water is flowing over, and continue on until you get to your desired crest elevation. And with a postless BDA, your last option is you can drive posts in afterwards, and this is a method we use quite often to provide stability and finish off your structure. I'm just going to walk through some time lapse of this process. So here you've got some rocks and wood in the way, so we move that out of the way and start making our base layer with branches parallel to the flow, and then packing in the dirt. And then there's a quick safety meeting to figure out if this was a good idea or not. And then it's back to building more layers, packing more dirt. And I can't stress how much dirt you need to pack here. This is a failed or breached natural beaver dam, and there's 3 to 4 feet of dirt packed on the front face of that particular dam to create that pond. So dirt. It can also be cobble or sod. Keep integrating your mattress as you go, and then finish it off at the crest elevation that you're shooting for. It's important to sort of figure out the spacing of structures, and so we generally build from downstream to upstream. And when there's water flowing and you build your first dam, the pond size that you create gives you an indication of how far your next structure should be away. But when the stream is dry or really low flow, you can just eyeball it, as Jeremy is demonstrating here with a very nice style and technique, as to roughly how far the next structure needs to be away from the one you're building. So the primary dam on the left here is the time-lapse structure that I just showed you, and then we built a secondary dam below that with the water coming to the base of the primary dam, again to dissipate energy. And the arrows on the bottom are showing the water is actually flowing now out onto the floodplain from that primary structure that we built. And here we're just looking upstream across the secondary dam, and you can see the water is going to the base of the primary dam and decreasing the head drop there and lowering the potential for that to undercut. All right, and now what you've probably been waiting for, the post line wicker weave building steps. This is a photo of an original wicker weave structure from way back in the mid-2000s in Bridge Creek, Oregon. You can see there's no mattress here, and we've improved this original wicker design over the years, and so I'm going to show the steps just for building the improved version. So you want to start with a post line, and it can be a single line or multiple lines or offset posts. As we mentioned before, they could be convex or straight, and either work. You might get a little bit more stability from the multiple and offset lines and have an opportunity to create a thicker weave when you have more posts, but we do find that both methods work. So you want to start with your weaving of material, and as we've mentioned in previous talks, it doesn't have to be willow. It can be literally any native vegetation that's readily available. And again, you want to build in layers, so 6 inches to a foot at a time, packing down the weave as you go. We see people often building the weave up very high without integrating a mattress or adding fill, and so that's really hard to get that sealed up and ponding water. So again, go slow, go in steps. We will often place a base layer of parallel sticks before we start weaving, and those branches would be the width of what you're hoping your base of your structure would be. So generally, 3 to 6 feet at least, and then you start adding your fill on the front side, integrating your mattress on the back side, and weaving your material across the structure in 6-inch to foot lifts of it, and just keep repeating that. And again, you need lots of dirt, lots of sod, lots of fill, so get yourself lots of buckets and lots of people. And here's an example looking upstream at a BDA in process, and you can see that they're integrating the mattress near the base as well, and so they're building the mattress up as well as the weave. And then finally, you want your fill material to reach your desired crest elevation and get that even water flow across your structure. And here's an example. All right, just to finish up now, some lessons we've learned from building, thousands of these PALS and BDAs over the years. We've built a lot of very simple and non-complex, non-irregular structures, and they have done some neat work in the past, and certainly you build structures with the material you have, but generally speaking, the more complex you can make these structures, the better. So here's just a list of lessons we've learned for both PALS and BDAs, and they have some similarities. Your orientation of the structure is more flexible with PALS. You want to form the shape with large pieces and then interlock as you go. Keep that width greater than the height of the structure. Large constrictions are usually better, irregular shapes, and don't worry so much about your crest elevation other than just the general bankful height. And then for beaver dam analogs, stick with perpendicular convex orientation, build slowly and in small layers of 1/2 foot to a foot. Really, really try to get that matrix of branches and fill and keep interlocking. Again, keep a nice wide base, wider than the height, and you want a level crest elevation and a nice mattress to dissipate that energy as the water comes over the structure. And if you do all those things and you build blocks or structures, you're going to be happy. And thanks very much.